Okay, so welcome back, and now we're going to take a look at end behavior for a function. So for example, end behavior, we're going to see that three things can happen for end behavior. So what do we mean by end behavior? It means what's the graph of the function doing when x goes to either positive or negative infinity. So in this case here we have three options. Either the end behavior is going to be where f of x approaches a horizontal asymptote, y equals L. So that's one option that we've seen. The other option is that f goes off to either positive infinity or negative infinity as x goes to positive infinity or negative infinity. So those are those infinite limits at infinity. And then the third option is that it does neither one or two. So it neither approaches a finite value nor does it approach plus or minus infinity. In this case, it might have some oscillatory behavior. Okay. Now, what we're going to talk about next is polynomial functions. Okay. So polynomial functions, as you know from your studies of pre-calculus and algebra, college algebra and such, that when we talk about end behavior, it's all about the leading term, right? And the leading coefficient. So we always talk about x to the n, right? The behavior of x to the n. And what we consider is whether n is even or is it odd, right? And so for polynomial functions, the degree being even or odd is important, right? So as we can see from just looking at x squared and x cubed, right? X squared, which is a parabola, right? Looks like that, right? And then all even values of the leading term will have end behavior act the same way. Okay? So this would be a polynomial with a leading term that has an even degree, right? So a polynomial even degree is going to behave this way if the leading coefficient is positive, or, as you know, it will open downward if the leading coefficient is negative, right? So if we have a c value, right? So if we have some c value, if c is positive, well, it's going to do this. If c is negative, it's going to do this. And then the degree, the parity of the degree, right? If the parity is even, if it's even degree, the tails are going to go in the same direction. So the end behavior will either go both up or both down, okay? Even though it might do something funky in the middle, right? Now, x cubed looks like this, right? It looks like this. So that's the x cubed function. So now, the thing is that all polynomials that have an odd degree are going to have opposite tails. So the end behavior is going opposite. It's going to look like this if the leading coefficient is positive. Notice that it has a general positive slope, positive direction, positive slope from left to right. Now if c is less than 0, then it's going to look like this. It's going to have a general downward slope going left to right. Okay? So again, make sure you're putting this in your notes, because this is going to be key of helping us determine what the end behavior is for polynomials when we do limits, right? Now we're going to be applying limits to polynomial functions. So this is one of the things that we can easily see where the limit is going based on what the leading coefficient is and what the degree of the polynomial is going to be. And again, this is more review from your days in pre-calc or even college algebra. Okay, have a great day.